Good morning, everyone. Welcome to the November Zoom Citrus Seminar. Thank you for joining us. First, I would like to thank Alison Walton from the Southwest Florida Research and Education Center in Immokalee for her help and cooperation. Today's program offers one CEU for pesticide license renewal and one CEU for certified crop advisor. If you need CEUs, email me your name, email address, and license number. Today's topic is about winter weather and FAWN. The first presentation will be on winter weather. There will be a discussion on the importance of reliable weather information, how this information can be used to make informed decisions on when and what citrus crop protection practices should be considered. There will also be a review of weather-related information services available to growers. The second presentation will be on Florida Automated Weather Network, FAWN. FAWN provides real-time data from its network of 47 automated weather stations every 15 minutes and uses the data to provide decision-making tools for cold protection, irrigation scheduling, and chemical application. This presentation will provide an overview of using the FAWN website as well as the recent system enhancements. In particular, details will be provided on recently installed weather stations, new sensors, and enhancements to the FAWN Cold Protection Toolkit. Our first guest speaker is Chris Oswalt. He is a multi-county citrus extension agent in Central Florida. Our second guest speaker is Rick Lusher, Director of the Florida Automated Weather Network, FAWN. Chris, please go ahead.
All right. Well, good morning and welcome today. I'd like to take a minute and talk a little bit about weather forecast information and how we can use the forecast to make informed decisions. As Mongi mentioned, my name is Chris Oswalt, and I'm with the UF-IFAS Polk County Cooperative Extension Service. I'm a commercial citrus agent like Mongi. I'm up in Bartow, and I'd like to share with you some of the information that we provide and some places where you can go to get information and the kinds of things that are important in making these cold protection decisions in your citrus groves. So we'll go ahead and get started. I just wanted to mention real quickly that most of the sources of forecast data that we get, the actual collection of that data actually comes from the National Weather Service. National Weather Service has offices all over the country, and we also have local offices here in Florida. The one that I deal with most frequently is the one in Tampa Bay, NWS, National Weather Service Tampa Bay. Also, the National Weather Service office in Miami. There's one in Melbourne, Jacksonville, Tallahassee, and also one in Key West. So there's 5 of them that basically cover the state of Florida. And what they do is they collect this information that comes in, and then they can better fine-tune those forecasts for their local geographical areas and come out with what I call the zone forecast, which are specific to, likely most times they're specific to counties, but even on the coastal areas now they've divided those zones. Well, they haven't divided the zones, but they divide the forecast. So you have coastal areas and inland areas. And so they even do that kind of stuff to provide better weather information for your specific location. But all that data basically comes from the National Weather Service. And since I've done a number of these talks, I tried to come up with something new that maybe you all haven't thought about or have seen before. So we're going to go through this and just talk a little bit about it. One of the things, the data that's so unique about, I think, about the National Weather Service and what they do is they collect weather information from the ground up to the top of the atmosphere, basically, every day. They launched these weather balloons. They've been doing it since the late 1930s. There's approximately 91 to, in this video I'm going to show here in a minute, he says there's close to 100, but those stations launched those balloons. In the United States, there's close to 100 of those stations. Worldwide, they do this release, and there's over 800 stations that release. And what they'll do is they'll collect this data that will allow them to then use these models, and we'll talk a little bit about these global models that then help them better determine what the atmosphere is doing, what is coming our way, and how it's getting there, and what are the particulars about the weather from the ground up through the sky or to the lower atmosphere. And what they'll do is they'll release these balloons. They typically take about 2 hours before they rise up to the point where they explode. They can get up to almost 115,000 feet, about 35 miles up. And they can travel out about 180 miles in that 2 hours and travel up to speeds up to 250 miles an hour. And what I did was I found this video that the city of Tampa did about the National Weather Service in Tampa, which is actually in Ruskin, about as a crow flies, probably 1.5 miles from where I live. The National Weather Service office is over there. And so this is actually from over in that office, and they explain what they do with these balloons and how they go up. So I thought I'd go ahead and see if this will work. Not sure about the sound. Hopefully you can give me some feedback. I haven't ever played a video in one of these Zoom things before, so let's see what happens. Got sound? Okay.
We're going to launch a weather balloon that we do here twice a day. Weather balloons are launched at about 100 sites around the country and really all over the world. Everyone around the world agrees to send them up around midnight and noon Greenwich Mean Time. That way, at twice a day, we can get kind of a snapshot of what's going on over the entire atmosphere, over the entire world. Attached to each balloon is an instrument package that measures temperature, relative humidity, pressure, and has a GPS tracker that can infer the wind speed. I'm gonna first prep the instrument package. It's comes to us already boxed up. We kind of take it apart and inspect to make sure all the sensors look like they're in working order. Then we'll go outside and we'll inflate the balloon with hydrogen and prepare the train, which below the balloon is a parachute and then about 75 feet of string that will then attach the instrument to. Good? I'm good. Watch my string here. The balloon goes up about 25 miles into the air. It gets to almost the very top of the atmosphere. And as it does, the pressure decreases, so it'll expand from about 6 feet at the surface to about 25 feet across when it explodes. It takes about 2 hours to get from the surface up to that top height. And the wind will blow it, depending on the day, in a number of directions. Usually our balloons, once they pop, will end up in either the Atlantic or the Gulf of Mexico. It can go up to over 100 miles away, especially when it lands. It could drift even further away from where it bursts at. It sends back data about every 0.2 of a second. We track it with a antenna here at the surface that can follow along as it moves up and down and moves from side to side. That data will bring in temperature, humidity, pressure, and wind speed and direction. From that, we calculate a lot of other more technical variables. Other than the rain happening right when I wanted to launch, this was a pretty smooth release. We're trying to sample everything from what's happening on the ground to what's happening each level of the atmosphere up to the very top. I'll continue to monitor the data over the next couple hours as it goes up each level through the atmosphere. Once it's finished, I'll send the data off to a couple agencies. One of them, the National Center for Environmental Prediction, they're the ones that run all the computer models for the United States. So really, we say the weather balloon data provides the backbone of data for the National Weather Service. Everything from long-range computer forecasts to thunderstorm potentials is derived from what we get from weather balloons.
Okay, are we back?
Yes, we are.
Okay, good. Hopefully y'all got a chance.
Demonstration.
Yeah, chance to take a look at that. I'm not a meteorologist, but I'm fascinated by all this stuff, and I've learned a lot over the years from people like Rick and the information on FAWN, and from all the other people that have helped me understand all this over the years. And just to reiterate about those launch sites, this is actually a map of those launch sites in the US and the United States. There's 91 of those according to this information here. As I said in the video, they're launched at 0 UTC, which is Coordinated Universal Time, which is Eastern Standard Time. It would be 6 a.m. and 6 p.m. So twice a day they launch these balloons. And as Tyler said in the video, this data is used as the backbone to running most of all of those global models that are run, whether they be models here in the US or the European global models the Europeans run in their weather forecasting. So this source of weather data, all this raw data comes from the National Weather Service. There's nobody else that I'm aware of. Rick may correct me, that actually do their own balloon launches, and if they did, they'd only be one or two of them likely, not enough to actually put together the data that's included in some of these models. And the one that we use most frequently, or I'm most familiar with, is the Global Forecast System, the GFS model. This is available. You can go online. This is a screenshot of the website that I go to, that we look at this data during the Winter Weather Watch program I'll talk about in a minute, which is what we do here in Polk County for growers. But we'll look at this data here. It gives us some idea of what's happening. You can look here, you can see the loops. They go out to sometimes over 14 days out. And the model present the data by atmospheric pressure. So at various levels, they don't tell you where they are as far as heights, but it's pressure. Typically 1,000 millibars, which I don't know if you can, where it says surface layer, you can see some numbers there. The 1,000 millibars is considered sea level pressure. 850 millibars is about 5,000 feet above the surface. And then the other one that we pay a lot of attention to, at least I do, is the 500 millibar, which is the 18,000 foot level, as that typically demonstrates where the troughs and the highs generally are located, and where that air may be coming from along those frontal boundaries. So that's kind of interesting. When you get up to the 200 to 300 millibars, you're actually up into the same pressure that is equated to the jet stream. So all this data is used to produce maps. They go from sea level above, and the weather information is used to forecast changes in the weather. So like I said, these things sometimes run out for as many as 14, 16 days. You can look at what those models predict over time as to where fronts, rainfall, different parameters that you may be interested in. And you can look at these models and you can see what kinds of information they produce that can help you understand what kind of weather may be coming your way, how much time you may have to get out there and do the things that you need to do before these weather events come. And basically, we talk mostly about cold weather here in Florida, at least with our weather program. There's a number of sources of forecast information. The public ones that I think of most come from the National Oceanic and Atmospheric Administration, NOAA, National Weather Service. We'd already mentioned this about the local offices and how they produce data. And there's a couple other places that I frequently go to. One of them is called, and hopefully this will work, is the Climate Prediction Center. And the Climate Prediction Center, okay, I guess everybody can see that, right? All right, and here's one of the maps that you can look at here on the Climate Prediction Center website, and you can look at the 6 to 10 day outlooks. And these are typically in general terms. They don't necessarily give you the finite data as far as a temperature, but you can kind of see what the trend is. And if you look at the 6 to 10 day outlook for the next 6 to 10 days, as far as temperatures for Peninsula Florida, they look to be on average going to be above average for this time of the year. And we're going to have above average probability of rainfall. And then you can look at the next map over and you can see how this changes over time. You can get these things into different outlooks. You can look at them a 1 month outlook. You can look at the 3 month outlook, and you can see what that data actually represents. Whoop, went back too far. Let me go back. So that's one of the places that that I go to look at what may be happening in the future, to look at that weather information, to see what may be heading our way. Another place that I look at is the Weather Prediction Center. And that's another location where you can see what's happening, and they do an overview. And you can look at the surface map, and you can look at this out 3 days. So you can see right now you've got high pressure sitting over Louisiana. You can see it starting to slip over towards Mississippi, Alabama, and then it kind of drifts off, and you see another cold front that's coming across the Midwest right now. Eventually, it will probably likely make it our way. You can look at the 3 day forecast and see where that front comes through and see whether it's going to push through. And it looks like about day 7. So there's another front that might be coming in about 7 days, which is valid for December the 5th. So this is some of the places that I go to get information. It's all readily available. Anybody can really get this information. It's just having the time and the knowledge to be able to understand what these things mean in terms of actionable practices that you can take out in the field. So those are a couple of places, at least from the public side of it, sources of forecast information. Now, there are other sources of forecasts, what I call private entities that may provide this information. One of the things you need that I always like to tell folks that the raw data typically is always going to come from the National Weather Service. Their models and their balloon launches are what are going to generate the data that most of these other services will tap into. And so when you look at maybe acquiring some private forecaster or service to help you with weather, you know, one of the questions that I always think of is, are the people you're dealing with, are they experienced in ag weather information? Do they know what you need? Sometimes that really doesn't matter. If you have experience in ag weather and you can tell them what you want, that kind of thing can work itself out. But someone's going to have some expertise in this as to how to take that information and what information is important to you as a grower and what information you need to make those decisions. And one of the things that I always say is consistency of information. If the service interprets the raw data, as long as it's consistent, it really doesn't matter, as long as you can make it applicable to your specific site or location, because it's very difficult to make pinpoint type forecasts. National Weather Service does, and Rick probably talked about that with some of the tools in FAWN. So you can get some of that information, but it does require some experience, and we'll talk a little bit about that too. There's also from services, there's commercial TV stations. They all have weather people that do forecast. If you can equate what they say the minimum temperature at the airport in Tampa is going to be to where your grove is in Hillsborough County, that's fine. As long as it's consistent, that will work just as well as anything, as long as you get the other essential data that you need to make those decisions. And there's other professional services that do this, like AEM, which is one that I just ran across from, and they do some contract work, I think, for some of the water management districts. Continental Weather Corporation is another one that's out there, and AWIS, which is out of Auburn, is one that's done ag weather for a number of years, probably close to 30 years now. So those are just sources of information. You can get them from the National Weather Service. You have private sources that you can get them from. One of the services that we provide at my office here in Bartow is that we have what I call the Winter Weather Watch program. This program provides forecast information. In the bottom there, you'll see it's not forecasting. We're not doing any forecasting. We're taking the weather service information that we get. We pull out what we think is important for ag producers, and then we try to give you that information so you don't have to hunt all over the place to find out what you really need to know. We'll do, the short-term kinds of forecast. We'll give you basically what you can find online, but there'll be the short-term forecasts where you'll see what the temperatures, high temperatures, wind conditions, cloud conditions, those kinds of things for a day or two out, minimum temperatures too. And then some of the long range stuff that comes off the Climate Prediction Center, where we'll look out 6 to 10 days and 8 to 14 days, and we'll provide that information too. It's all in one place where you can call up. It's basically geared toward providing information that I think is important to people in ag and ag users, and how that information can be beneficial to you. And we do have we've been fortunate in having additional expertise. Fred Crosby is still doing this kind of part-time now. He was pretty much our sole meteorologist for the last probably, I want to say, close to 30 years, probably not quite 30. David Fesash has come on here recently, and he's working with Fred as Fred moves towards full retirement. David's kind of helping us this year along with Fred, and we're trying to continue to put this program together and provide it for growers that choose to utilize this kind of information. Just to give you a little history about the program itself and where it came from, it's a service that's been historically provided by the citrus extension agents. It began back in the mid-1960s. I'm likely the last citrus extension agent that does this, but it began back in the mid-1960s, specifically after the 1962 freeze. They used to have a National Weather Service office in Lakeland, and they had one in Ruskin. One in Lakeland is no longer there, but the Ruskin office is still there. And what happened was that after the 62 freeze, there was a gap in being able to get this information to growers. And what this program does is it relays National Weather Service, and at that time, ag weather forecast to growers. Down at the bottom, I'm jump ahead. In 1996, ag weather became a special interest and is dropped as a product from the National Weather Service. So they still collect the data that they use to make the ag weather forecast. They don't make them anymore. We try to pull out that information, provide it to you. But originally, that was what this was a way to get growers this ag forecast information during times of a freeze. And one of the early ways to get the forecast was through teletype machines. And so some of the agents actually had teletype machines set up in the office that would get the National Weather Service ag forecast. It used to come out about mid-morning, 10 or 10:15 a.m. in the morning. And these teletype machines would put out the forecast, and then you had access to it. The agents would then provide this information to a recording system that had an unlisted phone number, and people that subscribed in the subscription basically goes to pay for the service and the phone lines and the equipment and those types of things. And so they got this unlisted number so that they could call in and get the official National Weather Service ag forecast. And at that time, back in the 60s, if some of you are old enough to remember this, a lot of the ag weather that used to come out back at that time was through AM radio. There weren't a lot of FM stations around. Most of them were AM, and you had commercial TV that would do forecasts, or you'd have to hear it on the AM radio station. Well, one of the things about AM radio back in the days is when it got dark, there were very few stations that would transmit at night. So as you got into the evening and needed timely weather information, you weren't going to get it from the radio because they were off the air. And you could call the National Weather Service, but again, today we have multiple lines you can call in, voice over IP, all sorts of, we have the ability for many phone calls to come in at one time, but you still are limited by the number forecasters that can talk to a grower at any given time. So what this did was the whole program was to provide you all growers with this weather information, this ag weather information, so you could get it in a timely fashion. You didn't have to call, get put on hold, get a busy signal. AM station goes offline, you don't have access to it. It was just a way to provide this information. And, you know, to this day, we still try to do that. We provide you with, you know, timely weather information at when you want it, because basically we still do the call up where you call in to a phone number, unlisted phone number, you can get those forecasts. So like I mentioned, and I hope I made this clear, it doesn't matter where you get your source of weather information. Consistency is the key to that weather information as related to your location. And so not every forecast is going to be tailored to your location, but if they're in a geographical area and you know how to adjust that forecast for your specific location, then that's the important part about this. Many of us probably know that when it gets calm and you get good cold air drainage, there are things that happen in Florida that you wouldn't think of. Cold air will drain and it will come south down towards Immokalee and then over to the south side of Lake Okeechobee. And those things that we know occur when it gets calm that may not always be reflected in a forecast, but if you know how to relate that information based on those parameters to your location, as long as the consistency of that forecast, they're forecasting that, and you know how to adjust it for your site, then that's the key to all this. I don't think it necessarily has to be perfectly specific to your site, but consistent to a site that you can adjust to your location. Some of the key things that I think are important in ag weather, things that you would really want to know, you'd like to know what the forecast minimum temperature would be. You'd like to know the wind. Is there going to be wind? What is the wind speed going to be? What is the direction of that wind? Is there going to be cloud cover? Is it going to be partly cloudy, mostly cloudy, not so cloudy? Not all clouds are seen. A lot of times you can have situations where you have real high clouds that are almost transparent from looking up in the sky that can still provide some benefit during a freeze event, and knowing whether that water vapor is going to be at those levels can make a lot of difference. So that cloud cover, whether seen or unseen, can be important, as will dew point. Dew point related to also wet bulb. If you use water for cold protection, most of us in citrus do, then your wet bulb temperature is going to be important too. Frost or no frost. One of the things that you look at is if frost is going to be a consideration, then you need to take that in when you're looking at the forecast. Are they going to be calm conditions? Are you going to have good radiation? Are you going to have frost? Is frost an issue? Frost formation actually increases the heat in the atmosphere or at that level. So it does slow the rate of fall, but if the dew points are low enough, so your frost point is below your critical temperature, then it's probably not going to do you much good. But if you're going to be concerned about frost, that's something that you need to be aware of when you're looking at these forecasts and information you can pull out, as well as the susceptibility of what you are protecting. So if you have something like a peach tree that's completely dormant in the wintertime, your susceptibility temperature is fairly low. If it's citrus and it's in full bloom, it's going to be much higher. So you need to know what that susceptibility is, what that critical temperature is to your particular crop. And so when we talk about freezes in Florida, there's typically 4 types of freezes that we consider. One of them is an advective freeze where the wind blows, and these panels down here are my attempt at trying to describe what those situations may look like. So an advective freeze is typically the first night when the front comes through and the center of high pressure that has all that cold air is moving into an area. You typically have wind, and what you'll see a linear decrease in temperature, as you see in this first panel all the way over here to the left, and you'll see that temperature pretty much drops throughout the night at a fairly steady pace. That's what we call an advective freeze. I know this because the wind panels are down here. I didn't put them on here so I didn't get a slide that was too crowded. So that's typically what happens in a advective freeze. You get a linear drop in temperature and the wind blows. Radiation freeze, on the other hand, is when the wind starts to calm down. You have periods of calm, and then what happens is as that radiation occurs, you can have differences in temperature. And in this particular situation, what I wanted to kind of show you is these are temperature sensors that were inside the canopy of a tree with a micro sprinkler running and the outside air temperature outside the particular grove. And if you look on the next day, the center panel, you can see where the inside canopy temperature is significantly higher than the outside air temperature. And that's because that micro sprinkler is running underneath that tree. And there is some benefit because the wind is not blowing. So you get that benefit from micro sprinkler irrigation within the canopy. And this is a large tree. It's not a young tree, a reset. You can see that difference there between that yellow line, that blue line, or orange line, yellow line, well, orange line and blue line. And if you notice in the first panel, there's not that much difference because the wind is blowing, it's mixing up the air. And so you see that situation is more of a radiation type condition. So you see that drop in temperature rapid after sunset, and then you get it bottoming out and you're down below a critical temperature, say like 26 for a significant period of time in that middle panel, whereas 26, you were only there for a short period of time the night before. And then the other one that is in this last panel, which I would consider last panel, is the unsettled kind of condition. The break condition is where you'll see a linear, or not a linear drop, but kind of like a radiation drop in temperature initially, first part of the night. Then the wind will shift to the northeast. And what will happen is the temperature will quit falling and actually start to come up and become warmer overnight. So that is what typically we call a break. The unsettled is I think like this third panel, where you look at the temperatures and you see it's a radiation. You can see the difference inside a tree canopy, outside a canopy, and then all of a sudden it bounces up and you start to see those lines come together. And in my estimation, based on this and what I know, is there actually was some wind that kind of mixed up the air, and that wind mixing up the air raised the air temperature in outside and also inside. But as soon as that wind died back down, you can see where the outside temperature dropped back down to about 31 degrees. So in this panel, you can see an advective, typical radiation, and then what I would call more of an unsettled condition. And remember, the break is when it breaks in the middle of the night, it doesn't get as cold as well, it could still be predicted to break, but your minimum temperature doesn't come at sunrise. It comes sometime during the night. As far as freeze protection, when we talk about citrus types of practices, typically we consider passive, which are done prior to the freeze. It's not anything you're going to do during a freeze, and active practices, which are practices that are done during the freeze event itself. Passive practice, typically we consider those things like site selection, historical data. If you have some experience about a piece of property you're going to plant in a grove, you know some particulars about it because you have some historical data, whether it's cold, whether it's warm. Elevation has a part in this. Cold air has a tendency to drain like water. So if you have elevation, then that cold air will a lot of times drain off. And then there'll be other areas, cold pockets or lower areas that accumulate that cold weather. Windbreaks can slow down the wind, things that you do ahead of time, and location to water bodies. So where are you in location to a major source of water, which could be a source of heat for the grove overnight. So you want to be on the south or east side of the lake, so you can take benefit of any wind that may blow across the surface of the lake and keep temperatures moderated to some degree. Another thing that you can consider are horticultural selections, such as rootstocks and scions. If you're in a cold area, you want a rootstock that can provide some cold tolerance to your scion, and you might want a scion that is going to be harvested before cold weather becomes a threat, so you don't have an issue where your fruit gets frozen. So those are things that if you're in a cold area, you can make those conscious decisions before time. Middle management is one of those things that we practice during the winter. We want to make sure we keep the row middles clean, free of rank growing weeds that can impede air drainage, create air dams that hold that cold air in a grove when you'd rather have it, drain off into these lower areas that might not have trees planted. When we talk about nutrition, there's no single mineral element that a citrus tree needs that's going to make it any more cold hardy. But what nutrition does is good balanced nutrition. If the tree is not stressed, it's going to be better able to withstand cold temperatures if it's in optimum tree health. And that includes irrigation, not over irrigating, but make sure the water status is good in the tree. And then with young trees, one of the things passively you can do, nobody does this anymore. We did a lot of work in the 80s on it, are trunk wraps or tree wraps. And just remember that tree wraps and their benefit is directly related to their insulating properties. So if you have something that doesn't insulate well, it's probably not going to provide you much cold protection. If something that insulates, has a higher insulating value, it's probably going to afford you some level of protection. Most of these do not add heat to the system, so they're just going to slow the rate of temperature fall around the trunk of a young tree. So they may provide some benefit if you choose to use these things. Most people don't anymore. They use just micro sprinkler irrigation. Some of the active practices that we talk about, grove heaters. We don't really use grove heaters anymore, but I have a picture of it, and some of us remember those. And so grove heaters always pop up in an active kind of way. Wind machines, there were some wind machines that there were some people that ended up getting some of those, and I think there was some cost share money available through the water management districts a few years back. And some people bought some wind machines. Most of those were my experience with those, most of them have been in blueberry fields, not in citrus groves, but they are a active practice that you can use, but they're limited to the specific type of freeze. When we were talking about those freezes earlier on, wind machine is not going to work in an advective freeze. Now, in a radiation freeze, an unsettled type of condition, they can provide some benefit. So they're an alternative, but they're not going to be usable in every freeze situation. Irrigation specifically, most of the stuff we do in citrus is going to be micro sprinkler irrigation. And so we had already talked a little bit about the benefit of that on those other slides when we looked at those different freezes where you can get some benefit within the canopy of a mature tree when the wind dies down. There's definitely some significant benefit there. Also on young trees, it's very beneficial when you aim it and you directly at the tree. You want to have that emitter on the north or northwest side of the tree. You want to have it within 3 feet of the trunk. You want it aimed at the tree so that you protect the bud union itself, because that's what you want to protect. And if you use water for cold protection, you really need to understand evaporative cooling. And when we talk about water and using water for cold protection, this is just basically a slide that I put together that shows that when you go from water vapor to liquid, if you look at the bottom, looking at the exothermic, so you go from water vapor, you get condensation, you get dew or frost, dew. It goes from water vapor to water liquid. So it would be dew. Say you reach the dew point, dew formed, there's 8,950 BTUs of energy, which are released when water condenses out of the air. Now, when that water liquid freezes to ice, which is what we do with irrigation, you get about 1,200 BTUs of heat added to the system. So understanding that is there's the potential for a lot of heat that you can add to the system. The condensation part of it to liquid or to ice, you really have, if it goes from a water vapor to frost, which would be a solid, and ice, you'd get that whole 8,950 plus the 1,200 at one time. And then you would run irrigation. You would continually add as that water froze. It went from a liquid to an ice, you would still be adding heat to the system. Conversely, if you have ice and it goes to a vapor, it skips that liquid phase. Most times you're going to lose all that energy. So that's why it's important that once you start irrigating or using water for cold protection, you need to keep freezing ice or freezing water to maintain a level of heat within that, because you don't want to end up in a situation where your dew or your wet bulb temperature and your dew points are so low that you're actually evaporating more than you're freezing. In that case, you're going to do more harm than good. And this is a slide that I took off of FAWN. Rick's probably going to talk about this, but it kind of looks at the risk level for evaporative cooling, the difference between the air temperature and the wet bulb. And the wet bulb temperature is essentially what temperature a wetted surface would become due to evaporative cooling. So you can look here and you can see at those different levels that we have for low, moderate, strong, high, and extreme. And then this is a chart that we've used for years and years, but I think it's important because a lot of times we look at, and we might have a standard idea that you need so many gallons per acre per hour to do protection. That's a starting point. One of the other things that I think you need to consider is precipitation rate, especially with impact sprinklers. But if you're talking about micro sprinklers, if you start looking at the amounts of water that you can put on a young tree to protect it, you can do some pretty good cold protection. If you think about the idea that you take a 360 10-gallon-hour emitter that has a pattern of about 14, 15 feet, it basically puts out about 1/10 of an inch an hour. Now, if you're protecting young trees, the recommendation is that you go to like a 180 or maybe even a 90-degree jet. So what that does is it increases that precipitation rate. So for the same amount of water, you're just directing it more efficiently on that tree. So if you have 1/10 of an inch an hour at a 360, you bring that down to 90, you're at 4/10 of an inch an hour precipitation rate. And if you look at this chart, just as a rule of thumb to look down through this, is the difference between 1/10 of an inch and 4/10 of an inch. You can do a whole lot more protection because of that precipitation rate. And that's just what it hopefully demonstrates for you. And then this is just one closing example of some of the things that we talked about as far as wet bulb, dew point, and air temperature, and what your critical temperature is. If you look at this particular graph, this temperature trace through time, you can see there where the blue line is the air temperature, the orange line is the wet bulb temperature, and the green line is the dew point. And as we talked about before about the types of freezes, you can see this very easily in these panels, is that first night when the temperature drops, it's a pretty linear drop. There's a difference between the wet bulb and the dew point, a significant difference, meaning, in my opinion, looking at this, I would say cold air is still coming into the area. Then you look at the second night, the temperatures aren't as high during the day. You start to see a little bit more of a steeper drop early on, but it's still pretty much linear, and you still have a difference in that wet bulb and dew point and the air temperature. And then that final night, you can see where or that third night, you can see where it drops off. And then the dew point, the air temperature, and the wet bulb all kind of come together at one point. That's typically what you'll see when the wind dies down and you have more of a radiation type condition. But the key here also is looking at that wet bulb temperature and realizing that if you turn on the water and you lose that evaporative cooling battle, your temperature, plant temperature, becomes that wet bulb temperature. So if you look at that first panel or the first night and you look there, the minimum temperature only gets to like 34, 35 degrees. If you ran no water, that's as cold as it would get. If you ran water and you lost the battle, you could have been as cold as 28. And then if you look at the next night, you can see there's still a significant difference between the air temperature and that wet bulb temperature. So you can see the importance of understanding that wet bulb temperature, knowing what it is, what the dew point temperature is, because it's related to this, and what that means as far as cold protection practices and what you can use. All right, that's what I had. If you all have any questions, I'd be more than happy to try to answer them.
Thank you, Chris.
You're welcome, Mongi.
Thanks to Chris for that great presentation. He does a really good job covering a lot of the conceptual aspects of freeze protection, and a great job of talking about the different data sources that are available out there. So what I'll do in talking about FAWN is apply a lot of what he talked about. And so what I'll do is I'll just give a brief overview of FAWN for anybody that might not be familiar with it. And then I'm going to show you some screenshots of our website and how to get to the specific data and tools that we have that will help during the winter. So the first thing I want to do is just show you a map simply of where we have weather stations. And we have 47 currently statewide. We do routine maintenance at each station about every 8 weeks. So we visit the station, we visually inspect, we clean, we function check rain gauges, and just do different things like that to make sure that the station is operating properly. And we also do a bit of data quality control behind the scenes. So all the data that we take in, we have some automated checks that we run the data through each day. And then if we find any, say, temperatures out of a certain range or something like that, it will send an email to us and let us know we need to keep an eye on a particular sensor or whatever. And we've been working with a data scientist here at UF over the last couple of years, and he is working on developing some more sophisticated data quality control procedures that will do a lot more than what we're even doing now. And as artificial intelligence becomes more common in data science and things like that, a lot of the state-run networks around the country are implementing these more advanced procedures, and we want to be right there with them. And it just adds a lot of credibility to us as a network, and it helps us simply have the best data that we can have for users. So quick overview of what we do. We provide data. We collect a lot of data, and we provide the data, and we provide forecasts. As Chris mentioned already, we don't do them, but we provide them in different ways. Freeze protection is probably the largest area of work that we do. Chris mentioned in his presentation that the Weather Service discontinued their ag forecasts in '96. And that was about a year before FAWN started. In the growers and UF and the commodity associations all recognized that growers needed a network of weather stations that was in areas that are representative of where agriculture was occurring. And as Chris mentioned too, the National Weather Service data, all that data is collected at airport stations. And so the forecasts that were being done with the data from the airports was not really helping the growers much. And so some money was obtained and some stations were set up in the mid '90s. And that's how FAWN started, largely in Lake and Orange counties. And we expanded from there. I think it was about maybe 15 stations in the beginning, and now we have almost 50. And so a lot of expansion, a lot of work, again, and largely in the area of cold protection. We also do irrigation scheduling, and we also do, we have a forecast tool for chemical application that just brings in the wind speed and rain forecasts. It just helps you decide if you're going to apply chemicals, what the optimum conditions might be over the next few days. So if you go to our website, and I'll show you the web address at the end, we have a fairly new GIS-based map that will show you the weather station locations and the current temperature at that station. And you can click over there on the left on different parameters you might want to look at. And you can also overlay. In this case, you can see the radar overlay there. And you can overlay a few other things. And that's pretty cool technology. And we're using that as much as we can. And as time goes on, we'll hopefully add more things that you can look at on the map. Data access is a big largely used kind of feature of FAWN. We collect a lot of data, we archive a lot of data, and a lot of people, even though we do provide different displays of data and data products, a lot of people want to just go get their own data and do their own thing with it. And so we provide different ways to access our archive data. And if you just click on data access across the top there, you can look at the different ways to access data. I'll show you a couple of those, but one of the things I want to mention at the top there is the air temperature threshold. That is kind of similar to chill accumulation. If you're interested in looking at the number of hours a station was above or below a certain temperature over a certain period of time, you can do that. The graphical weather data I'll show you in a minute. And the report generator is kind of just a form that you fill out, and you can download data in spreadsheet format. And then there's a couple of other ones there as well. So if you're looking at the home page and you click on a station, you get over to the right there, you get a kind of a quick display of several of the current parameters, and we update every 15 minutes. So every 15 minutes, we retrieve data from the stations, and then we put the data on the website and in the database and do the different tools and calculations with them. And if you click more at the bottom of that box on the right, well, actually, let me look at this first. Sorry, like Chris, I don't have the what slide is coming up, so I got a little bit ahead of myself there. So if you click on tools across the top, you can see the different areas where we have tools. Again, I mentioned freeze protection and irrigation, but we also link to a number of climate tools from the agroclimate group, which is the group at UF that does all of the long-term things like disease models and chill accumulation and climate outlooks and things like that. So FAWN focuses on the short term, the current data in the next few days. Agroclimate takes our data and does the longer term work. And so you can look, we link to a number of their resources. And again, one of those is the climate outlook. And so you can go to their website and look at the seasonal outlooks for different crops and things like that. Now, if you click on more at the bottom of the box on the right, you go to what we call the station page. This is where we'll kind of part for the next little bit, probably most of the rest of the presentation. You have all the current measurements from each site. We measure all the normal things: temperature, wind speed and direction, barometric pressure, rainfall. We measure temperature at 3 different heights on the tower. And we also do some calculations like evapotranspiration, calculate dew point. We do wet bulb and radiation as well. If you go, and then at the bottom there is a kind of a quick forecast over the next few days that we bring in from the Weather Service. If you go down the page on the left, just clicking on the different titles over there, the first one is graphical weather data, which is the same tool that I showed you in data access, but as it applies to, in this case, Alachua, which is just a station that I selected from the website to get these screenshots. What we've tried to do with this page here, this station page, is to take all of the tools and data products that we have and display them for that station on one page. If you're a longtime user of the FAWN website, you might remember that you'd have to kind of go into the tool and then drill down to the station that you wanted to look at. You can still do that, but we've also taken the station and then brought in all the tools and calculations as they apply to that station, so that you don't have to bounce back and forth between looking at the current data and then going out, to go look at the tool for that station. And so the graphical data is one of the ways that we did that. So you can look at the previous up to 7 days of several different parameters. And the graphical weather data is consistently the most widely used tool or page on our website, which is kind of funny in a way because it's just a data display. There's no fancy calculations. We're just showing the data on a simple graph. So it's kind of interesting to see that, that's still one of the most basic data displays we have, is the most widely used consistently, because it lets you look at the trends over the previous several days of several different parameters. The graphical forecast, which is the next link down, we bring in several forecasted parameters from the Weather Service, and you can see those in the drop-down box. One of those is wet bulb, and as Christian mentioned, that's an important one for winter, and so you can look at a forecast of that here on this page. We also show weather advisories that might be in effect for any of the stations, and so we just bring in the raw text of those advisories from the Weather Service, and we just show them in this link here. And if there are multiple advisories, those will display on the page and will show like tabs across the top in that blue area there. And so there might be, like this time of year, there might be like a fog advisory and a freeze watch or something like that, and it will show both of those. Chill portions is a calculation that we do that's kind of similar to chill accumulation, but it also takes into account the heating part of that, and it's kind of mainly for the blueberry industry, or the blueberry industry approached us about providing that calculation as it helps them put out different fertilizers and things like that. And so that is there as well. And showing multiple years helps in the decision-making process. So the main thing that I want to show is certainly the cold protection toolkit. And if you click on cold protection, the first thing that you see is a graphical forecast from the Weather Service. And this, you can scroll down here. So cold protection is actually a suite of several tools, and all you have to do is just scroll down to get the rest of them. So the first thing that we look at is a kind of a longer term forecast. And we have the temperature there, the wind speed and direction, and the rainfall over the next 4 days. And you can scroll to the right to see the rest of the forecast. And the nice thing about it being in this format is that you can kind of look and see when they expect temperatures to be, at the minimum levels. So you don't just get, well, it might be 32. You kind of get a time frame there that might occur. So when you're looking at an individual cold night, say the forecast there says, okay, Thursday it's supposed to be, at critical levels. When you get to Thursday night, you can look at our estimate of the overnight minimum temperature using the Brunt equation. And so you have the forecasted temperature in the forecast itself, but then you can look at kind of an additional forecast that uses the Brunt equation to estimate the overnight minimum. And then the forecast tracker lets you evaluate the forecast as you go through that night. And so in black on this tool, you have the current temperature at the FAWN site. And then in blue, you have the forecasted temperature at the FAWN site, or, at the grid that the FAWN site is in, that the Weather Service does that forecast for. And in this particular case here, you can see as the night kind of progresses, the actual temperature at the site starts to trend below the forecast. And I just, for demonstration purposes, put a 60-degree critical temperature on this graph so that you can kind of see how the tool is meant to operate on a cold night. You can see that the minimum temperature actually got below the critical temperature, in this case of 60 degrees, but wasn't forecasted to get that low. And that's what this tool can help you do as a cold night goes on, to see if the forecast, you maybe initially didn't think you would have to worry about temperatures getting too low, but then you start to see that the actual temperature is trending a good bit below that forecast. It might, that might tell you that you need to pay closer attention, because the actual temperature could get down to a critical level. But the opposite can happen as well. The forecast might be for temperatures to get down to a critical level, but it might be that as the night goes on, you see that the actual temperature trends above the forecast. So that might be a piece of information that would, help you determine that you might not need to be as concerned about temperatures getting too low. So it kind of works both ways. The next thing is the evaporative cooling potential, or irrigation risk. And Chris talked a good bit about evaporative cooling. He showed you that chart that he mentioned he got off of the FAWN site. And that's where that chart comes from, this tool. And so we take the wet bulb, we take the air temperature, we take the wind speed, and we evaluate the irrigation risk based on those parameters. And the idea is if you have a wet plant surface and the air is dry and windy, it's going to create additional cooling to that plant surface. And so we take those using that chart that Chris showed you, which is you can see view irrigation risk criteria there. That's the link to that chart. So we give you the current irrigation risk, and we also give you the forecasted irrigation risk. That's something that we just implemented. I don't know if we had that up last winter or if we worked on that after last winter, but regardless, it's up this winter. And so we take the forecasted wet bulb, air temperature, wind speed, and we evaluate the irrigation risk out into the future. And so you can see that there as well. And that's obviously very helpful when you're looking ahead in time. And then we give you a safe cutoff temperature. If you do run your system, we give you a safe cutoff temperature, again, based on the wet bulb and the temperature. And it's basically, that temperature basically says there's no further risk of damage due to evaporation if you turn off your system. And that gives you an air temperature at which you can do that. And then we have the citrus micro irrigation scheduler, and actually for several crops. I'm just showing the citrus one in this case. Going on down that page, the irrigation scheduler, we have them for multiple crops. And you put in some information about your particular operation, and then it gives you a recommended 2-week irrigation schedule based on our data and our crop coefficient calculations and so on. So that is the FAWN website and the FAWN cold protection toolkit. And just for regular users of FAWN, just kind of want to mention some things that we have going on in the near future. We just recently finished installing a bunch of soil moisture sensors from a NOAA grant, and we are working on adding redundant rain gauges to our stations to kind of help us quality check rainfall and to just give us an additional measurement so that we can ensure that we're providing good rainfall. And we have several new sites that we're putting up. And I mentioned the QA/QC already. And so this shows you a map of where we have stations, which is basically the same map I showed you in the beginning. The ones with the black dots show where we have soil moisture sensors. And we have them in all but 3 stations at this point. And then we have a couple of new sites that are going to be coming up in the near future. One is at the Nature Conservancy Blowing Rocks Preserve in Jupiter. Another one is at the DeLuca Preserve in Yeehall Junction. And then another one up in Niceville, which is up in the Panhandle. The soil moisture display I wanted to show you real quick. This is available on the website. I just skipped over it before because I wanted to mention it as part of our new things. But we show several. We initially started out just showing all the depths at one time, but we worked with Dr. Guzman up at Fort Pierce, who does a lot of work with soil moisture and does it in an extension capacity. And to kind of display the data in the most useful way, we are showing the different root depths of different crops and the soil moisture levels that are kind of critical to those crops. So in this case, you can see at the top, you can select citrus, and then we show the depths at 12 and 20 inches. And then at the bottom there, you can also look at the other depths. And then we show the rainfall if you look at the graph at the bottom there, you can see the different depths, and then also the rainfall amounts are the red bars that are on there. So it kind of, it shows you how the soil moisture reacts to rainfall. And then at the bottom of that, I don't show it here, but also the soil temperature at each depth as well. And we're measuring 5 depths, a 24-inch sensor. And then I always like to thank our FAWN gets quite a bit of funding from external sources, most of which are the water management districts. And so I just always like to, to thank them for their support, because we would not exist if it wasn't for them. And then there's our website if you don't know it. But if you just type in FAWN, it usually comes up pretty close to the top of the search engine. And that's it for me.
Thank you, Rick. Any question or comments?
I guess we did a really good job, huh?
Yes. Yes, you did. Thank you, Allison.
You're so welcome.
Thank you, Chris and Rick.
My pleasure.
You're welcome. Thank
And
you.
Thank you all for your participation. Again, if you are interested about CEUs, send me an email and include your name, email address, and license number. Thank you all for joining us, and see you next time.
Thank you.
Thank you.
Bye-bye.
Bye.